So it's really awesome to have Sukwoong Choi here to talk about something that I'm very curious about, which is how AI can help human decision making. I'm sure we're all very curious about it. Um, Sukwoong, we're delighted to have you. Sukwoong is a postdoc at the IDE, and he got his PhD at KAIST, and he's working on some really cool and interesting stuff. With that, just to remind you of some ground rules as we go. Please keep your microphones muted and your videos off to not distract. And if you have questions, please put them in the chat, and myself and Xanali will moderate. We'll break in if there's something clarifying, Sukwoong, if it's sort of pertinent right in that moment. Otherwise, we'll save a discussion till the end. And as usual, I have to teach at 1, so I won't be here to do the outro, but Xanali will be handling that. So with that, I will turn my video and microphone off and look forward to the talk. Thanks, everyone.
Yeah, thank you. Let me share the screen. Can you see my screen?
Good? Yes. Yep.
Okay. Hello, thanks for having me. My name is Sukwoong. It's a pleasure to be here presenting our work. Please enjoy my presentation with your lunch because this is a lunch seminar. The title of this study is How Does AI Improve Human Decision Making? Evidence from the AI-powered Go program. This study is collaboration with Namyo, Junshik, and Hyo. We have one big research question and 2 follow-up questions. Does AI improve the quality of human decisions? If so, what are the mechanisms by which the performance improves? Lastly, how does the effect vary by heterogeneous group? Our presentation summary is AI-powered Go program, we call it APG, significantly improved the quality of the players' moves. The key mechanisms are reductions not only in the number of errors, but also in the magnitude of the most critical mistake. In terms of heterogeneous effect, junior players benefit more than senior players. Interestingly, the improvement is most prominent in the early stage of a game when uncertainty and unexpectedness are higher. In terms of background, the availability of AI has broadened. In some domains, particularly, AI has already outperformed humans, such as medical diagnosis, drug development, and strategic gameplay. Recent studies of the AI effect mainly focus on 2 sides, such as the substitution role and assistant role. However, we do not fully understand the improved performance resulting from AI's assistant roles. This does not necessarily mean that AI nurtured fundamental human capabilities. Thus, our study focuses on instructional roles beyond assistant roles. In the literature, human decision-making is far from perfect. Individuals are limited in their ability to process information. This in turn leads to failure to optimize decision-making. This causes biases and errors, such as bounded rationality, cognitive biases, and myopia of learning. So decision makers tend to balance the quality of their decisions with the cost. There are some studies to mitigate these biases and errors. However, the benefits of these models are marginal. The advance in AI contributes to avoiding these biases and errors stemming from human judgment. With AI, the prediction became cheaper and accurate. so people can rebalance the accuracy of decisions at a lower cost. Furthermore, AI can evaluate a broader scope of options or alternatives, so humans can revisit their decision-making practices that have not been evaluated due to heuristics and cost limitations. Therefore, our main prediction is that AI can train human professionals and improve the quality of their decision. Age could affect the adoption and utilization of AI through three major channels: risk aversion, search behavior, and absorptive capacity. First, junior players are more open to new technologies and less risk-averse than senior professionals. Second, senior professionals tend to rely more on the knowledge and experience they have accumulated than do juniors. In other words, senior professionals conduct exploitative searches and make choices that are path-dependent on the past records. Third, younger professionals have a better absorptive capacity for new technology. The young are better able to recognize the value of new technology, assimilate it, and apply it to their professional tasks. Thus, we expect that junior professionals are more likely to be affected by AI technology than senior professionals. To examine our hypothesis, we use the context of the game Go. Some of you are aware of it, but for the others, let me explain it briefly. Go is a two-player strategy board game that originated in China at least 3,000 years ago. To play this game, you need a Go board, white and black pieces. The playing pieces are called stones. The Go board is typically a 19 by 19 grid, but we can also play a smaller one. By alternatively placing black and white stones at the intersection on the lines, two players compete to obtain more territory. More specifically, the object of this game is to get the most points. You receive points by either capturing opponent stones or controlling empty territory on the board. To the left of the slide, you can see the Go being played to capture the opponent's stone. On the right side of the slide, you can see that the white stone tries to control the upper left area and the lower right area, while black stone tries to control the upper right area. Shaded areas are shown potentially being able to occupy territories on board. It seems to be like a war to make better front to obtain territories in the empty space, right? As the game progresses, the resulting board is filled with stones, as shown in this image. Based on what I explained, what do you think about which one wins in this figure? Okay, I will give you 3 seconds to think about. 1, 2, 3. I think it seems that the white stone wins because white stone has the huge right territories in that game. I hope this explanation helps you to understand the game Go simply. If not, no worries. You will never work alone because Google DeepMind team mentioned that Go is the most complex game ever devised by humans. It means that it's just a super difficult board game with lots of variety, even though it's enjoyable. On the other hand, we want to emphasize that the professional Go industry is substantial in terms of playing countries and rewards. Since the historical match between AlphaGo and the human Go master, Sedoli, the APG has already outperformed Go players. How much better is APG compared to humans? In this figure, y-axis is the elo rating, which is a system for determining a player's capabilities. The best elo rating for human is below 4,000, while the recent AlphaGo is over 5,000. The gap is over 1,000 points, which means, unfortunately, it is almost impossible for a human to win against APG. However, in other words, we can see that this context is appropriate to examine our research questions. Indeed, this absolutely dominant power of AI has changed how to learn Go. In the past, as illustrated in the left three images, Go players learn from playing, tutoring, self-learning, and group discussion. But they could not judge how accurate they were. Rather, after releasing APG, Go players can be trained by AI, especially knowing the winning probability for each move. As you see, the light blue, orange, and other colored positions are displayed with the actual winning probability. Therefore, players can judge which move is better. For example, this game went up to the 98th move here. This turn is for the Blackstone. In that case, Jiseok-kim. If he selects the light blue position here, he will get about a 65% winning probability. Or he selects the orange colored position, he will get about 61% winning probability. It shows how APG actually works and how APG is used to change the training of Go players. Hence, many APGs are widely used by professional players and the public. For example, in the media, the Korea Go Association and the South Korean National Go Team mentioned that they are using Lila Zero for learning and training to improve their Go skills. However, because AlphaGo is the new algorithm, not a program, Go players couldn't use this algorithm. Instead, after 1 year, Lila was released after the first freely available APG to the public. Importantly, I want to note that the development of Lila did not come from the demand of or request by Go players. According to the interview from the developer of Lila, Giancarlo Pascuto said that the reason to develop this program is to learn how deep learning works. Simply saying, he just studied AlphaGo's paper and published the program. Therefore, this is not correlated with pre-existing conditions in the Go industry. Therefore, by using this release event, we compare how AI influences decision making. In order to do that, we collected historical professional games and professional Go players information between January 2015 to December 2019. Our unit of analysis is at the player game level. Our main dependent variable is move quality, which represents the average difference in the winning probability of the player's moves compared to APG moves. As it implies a gap from AI, a value approaching 0 indicates higher quality moves by the player. Using the APG, we calculated the quality for all the moves in our sample. This is the number of our samples moves. Particularly, we primarily focus on the first 30 moves for each game. This is because, like other games, such as Queen's Gambit, such as the chess, an opening strategy is critical to winning. Professional Go players accumulate their knowledge and wisdom, particularly for opening sequences. The early stage of the game is where APG can best challenge the knowledge accumulated historically by professional players. Our independent variable is cost. After the release of APG is equal to 1, otherwise 0. We consider we also consider the young. So young is also an indicator variable is equal to 1 if the age of players is below the median age of all players. In that case, less than 28 years. We consider the game and players' characteristics as a control variables. We consider player length, length difference for a game, and white represent who is the white player, and the types of the compensation types of the game, and player and opponent player fixed effect. Lastly, we use the model-free analysis, event study, and definitive test. We first present model-free evidence for move quality. This figure shows, sorry. Okay. This figure shows the weekly average value of move quality from 2015 through 2019. The vertical green line represents the release of APG. Before the release, this move quality trend is stable. However, after its public release, move quality increased immediately. When we formally tested with regression models, we find that the move quality increased by about 30% on average after the public release of APG. 30% is huge number, right? Previous studies suggest that age is an important factor in adopting and utilizing a new technology. As you can see, the red line is the old group, while the blue line is the young group. The figure shows that the move quality was relatively similar between the two groups before APG. The increase in the move quality is notably greater for the young group compared to the old group after release of it. We test the previous figure with regression models. We find that the effect of AI is consistently more prominent for the junior group. The quality of their moves improved by about 9 to 11% over the senior group. Considering the time-varying effect, the trend clearly reconfirmed our results. We also consider different exposure to AI between major Go-playing countries, which are China, Japan, and South Korea. Because AlphaGo events are only in China and South Korea, Japan may have relative low awareness of APG. To confirm this guess, we search the keyword AlphaGo during that match period from 2016 to 2017 in Google Trend. Interestingly, the results show that if China has 100 internet search volume, Japan has 5, which means that Japan has relatively low awareness of APG. Our model-free evidence showed that before the release of the APG, the move quality of players in the 3 countries was fairly similar. However, since the release, the move quality of China and Korean players has been higher than that of Japanese players. Therefore, we re-estimate the models with China and South Korea as a treatment group and Japan as a control group. Once again, we confirm that AI is indeed what improves the quality of moves by professional players. To check the robustness of our result, we conducted several tests. The first one is to check sensitivity for age. In the previous models, we used the median age. If we divide the age groups such as young, middle, and old, or consider the average age, our results are consistent. As a placebo test, if we randomly assign the age to players, we cannot find any AI effect. It implies that age is a meaningful factor to be affected by AI. Also, in addition, when we change the period of the games from quarter to month, our results are also consistent. Lastly, when we consider alternative opening moves, such as the first 40, 50, or 60 moves, the results are consistent. Based on these strong empirical results, we consider there are 2 important channels through which AI-based training improves the quality of moves, such as errors and the critical mistake. We measure the error as the number of bad moves in the game, while the critical mistake is the magnitude of the biggest drop in winning probability. The left side figure shows the model-free evidence for errors, while the right side figure shows the critical mistake. Both of them show a substantial decrease since the release of APG. The effect side is 2.2% and about 6% respectively. Thus, we can guess that the increase in move quality stems from the decrease in both errors and the critical mistake. Ultimately, we can easily come up with an idea that these improvements lead to winning in a game. with the mediation model to predict the actual win of a game, we confirm that young players, green box in this table, are more likely to win after APG through their improvements in move quality, errors, and the critical mistake, red box in this table. The effect size is about 5% to win for junior players. Lastly, we examine how AI influences depending on the stage of the game. We find that junior players' improvements is highest for the opening strategy and weakened as late stage moves were included. The value of this beta has decreased from first column to the first column, considering up to 30 moves in the game, to the last column up to 118 moves. And the value is the decreased, and the statistical significance was gone in the end. We can interpret this finding for two reasons, such as uncertainty and unexpectedness. In terms of uncertainty, at the early stage of a game, when only a few stones are placed, players have the highest number of possible moves. With AI, players can consider all possible moves, so they can learn a lot from APG. Another explanation is unexpectedness. As stones are placed sequentially in a game, the likelihood of facing another board with the same moves decreased exponentially. This implies that for later stage, more time is required to learn strategies from AI. As the concluding remarks, I would like to refer to the Weibo message from Choi, who is the professional Go player having the second world Go rating. Humans have evolved through thousands of years of actual combat exercises, but the AI-powered Go program has told us that humans are all wrong. Go players will combine computers to enter a whole new field and reach a whole new level. Our findings can be summarized in 3 sentences. AI improves the move quality of professional players, and young players benefit more from AI than old players, and the effect is more prominent for the early stage. Here are the implications of our study. First, AI reveals what humans believe to be the best may not actually be the most efficient way. It means that AI can train humans and help them make better decisions. Secondly, unfortunately, not everyone may enjoy the benefits of AI. The benefits can vary by age and nationality for our empirical results. Lastly, the impact of AI also depends on the unexpectedness and uncertainty of a situation. Thank you for your attention. I look forward to having a great Q&A session.
Thanks so much. Just wanted to ask a question and to channel Michael Schrag, who may also want to chime in with his question, which is really about how you establish the improved move quality. So at any given moment, when advice is given, there is a potentially large number of possible moves. Is there some agreed upon hierarchy of the quality of moves? And and from which there's like a distribution of the quality of moves from which you're selecting, or is it that the program has advice for the best possible move at each stage given all possible moves? So maybe a little bit of background about move quality. And then Michael's question is, you know, what portion of improved move quality do you assign, and you and the data assign, to bad move prevention and really bad move prevention? Are there no or only a few great move suggestions, recommendations? And then finally, I'm going to add to that because I think it's all part of the same set of questions, which is that I'm assuming that when you are playing a human, knowing that human and their personality and how they typically play, aggressive versus defensive versus long-term, short-term, they're aggressive in the short term and defensive in the long term, or vice versa, will change the nature of the move quality. And so how does adapting to the player fit into understanding of move quality as well?
Yeah, yeah, there are lots of questions, and then I think it's a really great questions, and thanks for asking me. In terms of the personality, I have one. I think it would be the future research, but I have. I heard that the Sedorly, who is the a fighter with AlphaGo, his moves actually quite aggressive. He's very famous as an aggressive player. So I'm not sure how can I capture the personality from using their game information, but I think we can capture. You can capture if there are lots of approaches in the early stage of the game. I think we can define this player is more likely to be aggressive player versus quite defensive player as well. That is my one idea. And the second question is from the Michael is what portion of improvement quality?
The question I asked was,
Yeah.
Hi,
Hi.
very interesting talk. Unfortunately, you've inspired a lot of questions, so I'll just stick with the one I posted in chat.
Yeah.
And that is, you talk about move quality, but you do not draw a distinction. You do not attribute the differences between avoiding a bad move and what you identified, the critically bad moves versus good moves. So on the indifference curve for improved moves, what portion do you assign to bad move avoidance versus good move recommendations?
I think in our study, we didn't consider these cases. Simultaneously consider both cases. We actually measure. I think not differently measure the three moves. So move quality, errors, and the critical mistake. But I'm not sure. I don't have an answer currently for which proportion has the bad moves in a good good quality moves. So yeah.
So just to be clear, what you're saying is the analysis that you provide highlights the importance of avoiding bad moves and avoiding critically bad moves, particularly early in the game. But it does not call out, here are the good moves or the good category of moves that are recommended.
Sorry about that. Could you elaborate? Sorry about that. Yeah, I'm really trying to understand.
So if I am playing, I am not a Go player, just to be clear. There are a lot of stones around there. So I'm going to stick with chess. In chess,
Yes.
there's a move you can make that can improve your offensive position, but you can also make a move that's a stupid move because you can forecast that it will create more problems than it solves on this. That makes it a bad move. So you have explicitly drawn a distinction between bad moves, but you don't seem to spend much time talking about good moves, moving the stone to a good place. So I just want to get insight into that, because it's one thing if you're telling me to avoid a problem. It's another thing if you're telling me to exploit an opportunity. That's the insight I want from you.
That's a great comment. But currently, I'm not sure. Sorry about that. But after this,
That's okay.
Yes.
That's why I'm asking. Pat, that's a conversation we'll take offline at another time.
Right. Yeah, thank you so much. Yeah. Great comment. Yeah, I need time to think about it. Yeah, sorry about that. Yeah. And is there any question?
There are a number of other questions. Irving's wondering whether you've published these results. The paper is posted. I don't know if this has gone under review, or is it under review, or is it just a working paper at the current moment?
Yeah, working paper.
Okay, perfect.
Yeah. So
Yeah, go ahead.
No, go ahead. Yeah.
I think it's Paula who's asking about human decision making and business implications. Can you describe how you draw conclusions to human decision making more generally and the business implications based on this research, or is it limited to Go, or can we extrapolate?
Yeah, I think the major issues in our paper to how we can generalize our results, particularly in business. So I just want to refer to the Simon. He just mentioned that, like, intuition from manager is also quite similar to the game of chess. So game of chess and maybe the other games, but he just mentioned that about the chess. So I think, and from the study, some usually managers handle lots of the manual work, maybe usually in a day, maybe that study is 70%, about the 70% managers use their time to handle the routine work, which means the AI can support this work, and AI is really focused on the specific task. So I think in the business world, we can also apply this specific task in the business world. So business world as well. So I think this study is a blueprint to think about, if AI technology applied in the business world, how human or managers will behave.
Cool. I have one more question, and then I'm going to have to run to class, and maybe Zanali can take over. But so it seems to me that in the context of these types of games, whether it's chess or Go, we're talking about a strategic interaction between two sides, right? So there's forward-looking behavior. There is attempts at subterfuge and trying to throw people off, thinking you're doing one thing when you're actually setting up something else. I mean, some of the most famous games of chess in history are situations in which two highly analytical players who each know many iterations of strategy, whether it's a certain opening or a certain gambit or whatever, where games are decided in some sense on the notion of surprise. So I'm thinking about there's a famous match between Fischer and Spassky in which Fischer is very surprising, and that has a lot to do with why he wins, because the idea is that, you know, when facing a calculating machine that can sort of figure out the probabilities, in some sense, uh, you know, throwing them off, having them believe that there is a certain path dependence to a set of choices that are coming, whereas you are really shielding the true strategy as a surprise, is part of the game. And so I'm wondering whether, you know, the suggestions and or the player's likelihood of taking or not taking suggestions, you know, thinks this far ahead, or whether it's really just at any given point the suggestion is the best possible move, conditional on all possible moves being available going forward, or whether whether the suggestions are sort of forward looking in the sense that they consider a multiple move strategy and what the likely counters of that move are, or in any moment when a suggestion is given, is it, given this current position and the possibility of all counter moves and all moves that I might make in the future, my best move to maximize the probability of winning points in that moment is X, and therefore I'm going to suggest X. Which of those two types of suggestions are given here?
In my understanding, the last one, the latter is the right. So you know, the AI cannot suggest anything if we didn't start a game, and then if we start a game by placing each move between white and black player, and then AI can suggest, given that situation, and then given that situation, and then suggest the highest the options having the highest winning probabilities, maybe less than 5 or 6. They already decrease the options, and then they just suggest like some 3 or 4 moves to do that. And interestingly, but you know, as a players, they can follow the AI suggestions, but it's quite, as I mentioned, that like this in the early stage, they can memorize some sequences, but as the complexity increased, we cannot just follow the AI suggestions because we did not memorize all of the things, and then the status of games is always not the same. So I think that is the reason. I think that question is quite relevant to my studies, the boundary conditions. So that is the reason, you know, the AI, the effects of AI is constrained by the early stage of the game.
I mean, you know, just to follow up, just a quick comment. You know, I've played Go a couple of times, but I don't play it as much. But I play chess, and you know, there is a fully, you know, I love the whole concept of like, you know, chess has so many possibilities at any given moment. But two experienced players who are playing where they have a certain opening and a certain defense, those options collapse very rapidly into a series of expected moves. And it's really deviations from the expectation that are strategic rather than playing the optimal set of moves necessarily. So it turns out that, you know, maybe suboptimality turns out to be strategic, because, you know, like that's the whole concept of a sacrifice in chess, right? Like
Right.
you are giving ground and points in order to set something up 5, 6, 7 moves from now.
Right.
And I don't know whether that's captured in these suggestions or not, is sort of my question. Thank you.
Yeah. Thank you.
Yeah, it sounds like Sinan has class, so I can take over in terms of facilitating Q&A.
Yes.
I'm wondering if you could talk a bit more about this result around young players versus old players. So you talk a bit about in the paper why this might be, you know, to what extent is this about, you know, experience? It's not exactly straightforwardly mapped onto experience, of course, as you said before, but yeah.
So we're gonna, yeah, I think this is really a great comment, and then we will examining the two cases, like the young players has a lots of have a lots of records of the games, but and in this case, and there's some, I mean the other case would be the young players having the really lowest case. We just want to try to compare that part as well, and then even the old players, some of them has a lot of game records, while the others has a less game records. So we try to examine, considering this experience part as well, using the records of how many games they are doing in this video. Thank you.
Let's see, are there any, questions I missed in the chat? Oh, Jerry,
It's Michael here, Zanil. Can I just ask one quick follow-up based on your question on age?
Yes.
Speaking as somebody who is older, I'm going to offer a hypothesis that I'd like you to test. Going back to the bad move versus extreme bad move.
Oh.
It's possible that the main reason why AI is helpful to younger players is that because, as you point out, they are risk prone, they are more likely to make riskier and stupider moves. My apologies for the aging discrimination question there. But is that something that you built your model for?
Yeah, that was very insightful, comment, and then I will try to check after this, presentation. Yeah, thanks.
Thanks. That makes me feel better.
Yeah.
And Jerry, similar looks like has a question about this age question. Did you explore the age variable beyond just deciles? Is 40 plus really the definition of an old Go player?
Yes, you mean the categorization of the age?
Yes, so that age variable.
Yeah, in that case, when we confirm that the only young group has more benefit from AI, not middle and old group.
I guess I was asking, is it you put people in categories 20s, 30s, 40s? If
Yes.
you made it a continuous variable, was there a trend or was it a market different by the decade differentials? And is 40 really the kind of upper bound of what you would consider an old Go player?
As I mentioned that I just used the two categories, two standard at the beginning, like some median of age of players and then the average. And this category, like some 20s, 30s, and 40s, when we see the distribution in our samples, so we can divide these three groups. So that is the reason we consider the three groups to conduct robustness.
So I guess this is probably in the paper, but so can you repeat? So like what percentage would you say of Go players are like over say 40 or?
What I remember, like some 20% is the for over 40, I think.
Okay.
Jerry, I think the conclusion is that people like you and I should be playing shuffleboard.
Oh.
I was going to extend this and see if you've also looked at applying these techniques to poker, since there are now AI programs that can beat professional poker players.
That's a good question, Jerry. And also, yeah, if you could talk a bit more about kind of what you think maybe future work, follow-up work along these topics, whether looking at other games or settings like poker, or thinking about, yeah, I guess kind of where do you see the kind of this work in the future?
Yeah, it would be also interesting in examining another games like chess and maybe StarCraft. They are also the debated. But I'm also think when I conduct this research, I liked this part, like the existing knowledge, which we believe it was the best knowledge we can imagine or we can conduct it, but it was not that efficient as efficient which we thought. So I think it's also similarly, we can see that in the medical diagnosis, when we see the X-ray for the breast cancer, when I read the newspaper, the doctors, they miss some cancers in the X-rays, but AI can find this area. So I think that is the differences of the marginal knowledge between humans and AI. So I really focus on this part in the Go case and the medical diagnosis case. So because even though the knowledge would be the marginal, but the benefit is much bigger. In particularly even in that case, it would be our lives. It's very relevant. So I think I really want to expand our research scope to them.
Awesome. Yeah. I mean, human decision making in medical diagnostics is yeah, a big part of their task. So I think, yeah, that's really maps on well to that area of research. Looks like those are all the questions that we have in chat. I'd love to just thank Sukwoong again for his presentation, and do maybe a quick round of silent applause or unmute if you are willing. And next week we will have, who will we have next week, honey?
All right,
I believe next week we have Sandil Mullainathan.
Oh yes, awesome. So you can join us next week to see Sandil's talk.
Yeah, thank you so much.
Thank you, everybody.
Thank you.
Thank you.